Hello and welcome to another Java video tutorial. In this tutorial we're going to spend a little bit of time talking about Unix time. Okay, so what is Unix time? Well, in Java and in other programming languages and operating systems we have to have some way of representing the current time. And the way that that's usually done is using a method called Unix time, or often called Epoch Time. The idea of an epoch is that we pick some point on the timeline and we mark that point on the timeline as a known point, and then we count the amount of seconds that have elapsed since that point on the timeline. So that point on the timeline is known as an epoch. Now we can count backwards as well by just counting negatively on the timeline, so we can also represent times that are prior to that epoch time, that point on the timeline, by just counting in a negative direction. So we can count forward and we can count back from a particular point on the timeline called an epoch. Now, as it happens, there are actually many different standards of epochs that are used in different situations. For example, Microsoft Excel uses January 0, funnily enough, 1900 as an epoch time. Apple's Cocoa framework and development framework for developing iOS apps and so on uses January 1, 2001. GPS devices happen to use January 6, 1980. And famously, Unix, the Unix operating system, uses January 1, 1970 at 0000 hours as its epoch time. So by picking a moment in time and then by counting the amount of seconds, or maybe milliseconds, that have elapsed since that time, that gives us the current time. It might sound like a very strange way of storing time, but it actually is quite simple. It's a very simple way to store time. The problem lies in the fact that as humans we don't see time that way. We see time as more kind of human readable times, as in a month, a day, a year, an hour, a minute and a second. Okay, so we combine all of those different ideas into what we kind of understand as now. Computers don't think the same way as us, obviously, and they are far better at dealing with time as just some big number of seconds that have elapsed since some known point in time. So that makes it countable. So really that's what we talk about when we talk about epoch time. And that's the way our programs actually deal with time, and that's the way they represent the current time, as we'll see in a little while when we have a look at some examples. Okay, so now that we kind of understand what epoch time is, we need to have a little bit of a history lesson, because the idea of epoch time was kind of made popular by the Unix operating system. The Unix operating system was developed in the early 1970s. It was developed by three very famous computer scientists, Ken Thompson, Dennis Ritchie, and Brian Kernighan. And they worked in Bell Labs, and they developed a Unix operating system called AT&T Unix at Bell Labs. And they built into the Unix operating system this idea of epoch time, or what was soon to be kind of referred to as Unix time. And Unix time refers to that epoch in time, January 1st, 1970 at 0000 hours. So that was kind of made famous and became a standard then after that, when Unix gained popularity and was used in a very widespread way. A lot of other systems then just began to use that standard Unix time. Now, Thompson, Ritchie and Kernighan are obviously very famous computer scientists, and Unix is what it is today, and all the various flavors we have of Unix today because of those three guys. And I like to include Brian Kernighan in there as well, because Brian Kernighan wrote quite a lot of the useful command line tools that we use in Unix today. And of course, Dennis Ritchie and Brian Kernighan are famous as well because of the book that they wrote together on the C programming language. And of course, Dennis Ritchie who wrote the C programming language, co-authored that book with Brian Kernighan. Brian Kernighan kind of wrote the first kind of manual, I suppose, if you like, for the C programming language along with Dennis Ritchie. And of course, the Unix operating system was written in the C language. So all of these things go very much hand in hand together as part of history. So that's an interesting little kind of thing to look at when we begin to look at Unix time and the idea of epoch time and where it came from a historical point of view. Okay, so Unix time is defined as the number of seconds that have elapsed since 0000 hours January 1st, 1970, right? And we count the number of seconds forwards. We can also count the number of seconds back from that point in time as well. And originally, that number of seconds was stored as a 32-bit signed integer. Now that causes a bit of a problem when we stored the number of seconds elapsed as a 32-bit signed integer, because we run into a bit of an issue when we reach the maximum number that that 32-bit signed int can store. And as it turns out, that will happen in the year 2038. In fact, we will not be able to store times after the year 2038 at 0300 hours 14 minutes and 7 seconds, because if we try and encode times or try and store times after that point in time, what will happen to that 32-bit signed number is that it will rotate around. It will reach the maximum number that it can store, and then it will wrap around to a negative number. And that negative number that represents Friday the 13th, December 1901, rather than the date that we want it to represent. So that is known famously as the year 2038 problem. Now, luckily enough, most of the issues with storing the time elapsed since January 1970 have kind of faded away, because we don't have an awful lot of 32-bit systems left around, and also a lot of our programming languages have changed now. They don't store the current time in a 32-bit signed integer, so a lot of those problems actually will have, disappeared. Hopefully by the year 2038 we won't actually run into this issue. But it is an interesting thing to look at when we decide to use kind of an arbitrarily sized piece of data to store a concept like time. We may run out of space to store that number after a while, and as we see, it will actually happen in the year 2038 if we have any 32-bit signed integers around that are still storing time, or Unix epoch time. So that's a bit of a problem. We'll see how that was fixed in a few minutes. We'll get on to that. But it would be interesting for us to have a look at how some of these numbers are represented. Like what exactly is a 32-bit signed integer? Well, we know that integers have a sign, don't we? We know that we have a minus in front of a number represents a negative number, and a plus in front of a number represents a positive number. Now we tend to leave out the plus. We don't actually ever really write it down. The absence of the minus in front of the number represents that it's a positive number. But we need to represent that idea of sign, okay? So when we have a 32-bit number, we actually use one of those bits to represent the sign bit. So one of the bits of the 32 bits is actually used to represent the sign component, and the rest of the bits, the other 31 bits, are used to actually represent the number part of the 32-bit signed integer. And that bit that represents the sign, the minus, is the most significant bit of that bit string. You'll see that in a second. We'll have a look at an example now to kind of illustrate that. So let's take the number 25, for example. So we're used to dealing with numbers in base 10, in decimal. So the number 25, obviously in base 10, is 25. In binary, or base 2, the number 25 is 11001. Okay, and if we represent that as a 32-bit binary string, we'll see that on the right hand side of the string we have the numbers 11001. That represents the number 25, and on the far left of that bit string, the most significant bit, that represents the sign part of the number. Now if that bit is 0, then it's a positive number, but if that bit is set, if that most significant bit is set, well then that represents a minus number. So that bit string is almost the same for a plus 22 and a minus 22, except for that most significant bit will be set to 1, where the number that we need to represent is minus 25. Okay, so that's kind of what it looks like in binary format. So let's dig into this a little bit deeper then. How do we, convert that bit string, or how is that 32-bit signed integer actually converted back into a number that we understand? Well, there are lots of different ways we can do this. One of the ways, kind of visually, we can do it is if we look at the entire 32-bit string and we look at the significance of each of those bits in the string, then what we can do is we can take any of the bits that are 1 or that are set, and we can look at the significance of that bit, and we can add up the significance of the bits that are set to 1, and then we get our number. So for example, with the number 25, if we take that 32-bit string, and if we look at all the bits that are set to 1 and the significance of those bits, we'll see that, well, there's a 1, the leftmost one has a significance of 16, and then the next one has a significance of 8, and then 4, well, that hasn't got its bit set, that's 0, and 2 hasn't got its bit set, that's 0 as well, but the 1 has got its bit set to 1. So if we add up those components, 16 plus 8 plus 0 plus 0 plus 1, we get 25. So that's one way we can convert that binary bit string into a decimal number. We can look at the significance of each bit. If the bit is set, we can add it up and we get the number 25. Now, of course, the most significant bit in that bit string happens to be set to 0, so it's a plus 25. If the most significant bit, that leftmost bit, had been set to 1, we'd be dealing with minus 25. So you can see that if out of our 32-bit string, we actually only have 31 bits that can actually store the number part. Now imagine for a moment if all of those bits were set to 1. If every bit was set to on, well, that would represent the maximum number that we could store in a 32-bit signed number. Now remember, only 31 of those bits are used to actually store the number. One of the other 1 bit is used to store the sign. So the actual maximum number that we can store is 2,147,483,648, which sounds like a big number. It is a pretty big number, 2 billion and something. But that maximum number gives us this limitation. That maximum number gives us this year 2038 limitation, where we run into that problem where if we try and increase by even 1 more that number, we wrap around and it becomes a negative number, and then that's not good because it's not representing the current date. It represents that date in the past. Okay, so that's obviously bad. Okay, so that's a bit of a problem. We need to get around that. How do we get around it? Well, most modern systems now represent the current time not as a 32-bit signed integer number. They represent it as a 64-bit signed integer number. So we have doubled the capacity, if you like, in terms of the number of bits that we can use to represent the number. Now, even in a 64-bit number, that first bit, that most significant bit, is used to store the sign. So even in a 64-bit number, only 63 of the bits can actually be used to store the number part. But what that does is it vastly increases the size of the number that we can store in that space. In fact, when you look at the number, as you can see there on the slide, it's a pretty big number. That maximum signed 64-bit number represents 9,323,372,36,000,000,000. It's a big number, okay? And what that does is that pushes the problem out so far into the future that that limitation, that upper limitation on a 64-bit signed integer number becomes unimportant, because that maximum number that the 64-bit gives us represents a number that is estimated, that is 3 times greater than the age of the universe, or approximately 292 billion years into the future. Now, if any of our operating systems or any of our programs are still around at that point in the future, we've got a big problem. I don't know how they are still there, because it's quite likely that the Earth might not be here, or definitely the human race might be here. So it pushes the problem so far out into the future that it becomes irrelevant. And 64 bits is plenty enough space to be able to store the current time in terms of an epoch. Okay, so the other thing that I want to mention about this is this idea of a 64-bit number. When we look at computer programs, we usually have a number of inbuilt kind of simple data types. One of them, of course, is the integer data type. Now, the integer data type in most modern programming languages represents a 32-bit signed integer, okay, the int type. Where we want to store numbers much bigger, such as the current time, the number of milliseconds that have elapsed since Unix time or Unix Epoch time, we shouldn't use an integer. We should use this idea of a 64-bit signed integer value. Now, in programming languages, we have a special type called long that represents that 64-bit number, okay? In Java and in C and other languages, it's called long. There may be other variations of it, but in most languages, the data type is represented as the word long or the keyword long. Now, just the way we can introduce an integer variable in our programs, we can introduce a long integer into our programs just by using the data type long. So just like declaring an int, we can declare a long, and it's just another number, except this number is a 64-bit number and capable of storing a much bigger number than a 32-bit one. Okay, so how do we represent dates and times in Java? Well, Java uses this concept of epoch time, and it uses the Unix time as the point on the timeline where it counts forwards and backwards. So we have a bunch of libraries in Java and multiple ways of grabbing the system time in Java. And this idea of the system time in Java, of course, is this Unix time or epoch time. So what we're going to do is we're going to take a look at how we can grab the current time in Java and how we can deal with that and print it out, and how we can begin to manipulate the idea of dates and times in Java. Okay, so on the slide there, I've got two examples of how we can grab the current system time. One way we can do it is we can use system time, or we can say system.currentTime milliseconds, and this will grab the current time and it will give it back to us as long as the amount of milliseconds that have elapsed since January 1970, okay, or January 1st 1970 at 0000 hours to be more precise. The other way we can do it is we can create a date object. Java has an inbuilt date object that we can use, and if we create one of these date objects, it will actually create a date object, and by default that date object will have the current time. So we can do it in those two ways, and there are actually other ways to do it, but let's not confuse things with more ways to do something. I've already given you two that are perfectly usable, so let's just have look at an example that uses those. Okay, so very quickly I'm going to go to my editor window. Okay, so what I'm going to do here is I'm going to develop a little program. I kind of have some of it already written, just a little template. I'm going to develop a program called time example. I've got my main method here, and in my main method what I'm going to do is I'm just going to do the little example that we can see there on the slide. So I'm going to say long UT1, that stands for my variable long. UT1 stands for Unix Time 1. Now remember, the long here, that's just like an int, except long is a 64-bit version of that. Okay, so it's capable of storing a much bigger number. And we need to make sure that we use the long data type when we're dealing with time. Okay, so long UT1 equals System.currentTimeMillis. Okay, so that's one way to do it. That grabs the current time from the system. Okay, now where does it get it from? Well, it gets it from the operating system. So whatever operating system you're on, that's where the current time will be grabbed from. So your operating system maintains a clock. Okay, you've got a clock in your computer. You've got a hardware clock in your computer that's ticking away all the time. And the operating system runs on top of that hardware, and the operating system maintains the time. So when we make a call to System.currentTimeMillis, well, that's asking the operating system effectively, hey, what is the current time? Okay, and that's going to give that back to us in our variable called UT1, and that's of type long, which is a 64-bit signed integer. Okay, let's print that out. Let's say system. Let's print it out. System.out. I can just use a println here just to make things a bit quicker. Well, I can spell it right for a start. Println, and I'll print out UT1. Okay. The other way to do it, of course, is to create a date object. Now, Java has its own date object, or should I say, its own date class. Okay, it's not a date class that I've developed. It's an internal date class that Java has. And the date class is actually part of a library, or part of a package. So I have to import this package. So I can import java.util.date. So date is part of the util package in Java. So I can import that, let Java know that I want to use this date class that it has. Okay. So what I can do is I can say date, and I can give my date object a name. So I can say now, let's say, and then I can say equals new date. Okay, now what that's going to do is that's going to create a date object, and that date object, when it gets created, will have by default the current time. Now it won't be a date like a month, or say a day, month, year, and a time. It will be the number of milliseconds that have elapsed since our Unix time epoch. Okay, that's the way it stores it internally. All right, so don't get confused just because this is called date. Don't think it's a nice formatted date. It's not. It's an epoch time. Okay, so we create that date object, and then what I can do is I can get the epoch time from that. So I can say UT2, for example. So I can create another long variable here, UT2, and I can say equals now dot get time. So for me to get the epoch time representation of this date object, I can call the dot get time method to give me that milliseconds elapsed representation of the time. Okay, I can print that out as well. So I'm just going to copy down my print ln statement here, and instead of printing out UT1, I can print out UT2, for example. Okay, let's actually save this and see what happens. So I'm going to save that. I'm going to go to my terminal window here. So I've saved my program, and I'm going to compile that. So I'm going to say javac time example.java. And okay, so it's compiled, and then I can run it. So I can say Java time, and we can print that out. Okay, let's have a look here. So you can see that we have our two times. Okay, so one of them here is created using this method where we use System.currentTimeMillis, and we store that in our variable ut1, and we print out ut1. Okay, and then we create a date object, and remember the date object, when it gets created, it will have by default the current time. And then I can say I can create another long variable ut2, for example, and get the milliseconds elapsed since Unix Epoch time, and it's stored in ut2, and then I can print it out. I can print out ut2, and I get my output here on the screen. Okay, so that's two ways of getting the current time on the system. All right. Well, what about if I want to actually represent? What about if I want to represent the time on the screen, or print the time out in a better format? Like these numbers, these numbers that we see here, in our output, they don't really mean very much to a human. That's just a big number. Doesn't really mean anything in terms of time. So what I've got to do is, when I want to actually represent that in a better way, I've got to convert that number of milliseconds elapsed from that number into something more readable in terms of, a date and time that a human can understand. So that's the next thing that we need to do. Okay, so what we're going to do is we're going to look at a way to do that. And one simple way to do that is to use another Java class called SimpleDateFormat. And SimpleDateFormat is a class that allows us to specify a date and time format using a format string, and then we can use that SimpleDateFormat to take an epoch time and represent that epoch time as something more human readable and understandable. So let's do that. So in order to do that, I need to also import java.util.SimpleDateFormat. That's also part of, actually it's not part of the Java util library. In fact, it's part of the java.text package. So I need to import java.text SimpleDateFormat. Okay, so that's not part of the util, that's part of the text package. Okay, so when I import that, I'm able to use it. So as you can see there on the slide, we have an example of how to use the SimpleDateFormat. We just give it a string a string format, and it will take the current time in milliseconds elapsed, and it will give us that time back in that format. Okay, so as you can see here, I have imported my java.text.SimpleDateFormat. So I've added that up the top here into my code. Okay, and what I can do now is I can format these dates. So I can say something like, let's create a simple date format object. So simple date format, and I'm going to call this date format equals, I have to make my text a little bit smaller here, simple equals new simple date format, and I have to give this format string. So the format string is interesting because you can actually have lots of different format strings. So the best thing to do is go onto the web and have a look and look up the simple date format in the Java documentation, and you'll see there is lots of different ways that we can represent dates and times, and lots of different format string specifiers that we can use to build all sorts of different date formats and time formats. I'm just going to use a pretty standard date format that we use pretty much across Europe. I'm going to specify a DD, which is going to stand for the day component, which is 2 digits, and then we're going to have two numbers that represent the month. So I'm going to say DD, and I'm going to use a / as my separator. Okay, and then I'm going to have two capital M's. Now the capital M's are interesting because we also have a way to specify time, and there are minutes and time. So the smaller M's are used to specify 2 digits for minutes in the time format, as we'll see in a second. But the capital M's are used to represent a 2-digit month. Okay, so there are lots of different format specifiers that we can use here, and again, you should go and have a look at those. Look up the SimpleDateFormat class in the Java documentation. So I'll say DD / MM / and then YY for the year, and that will give me a 4-digit year. Okay, and then I'm going to have a space, and then I am going to specify the time component of this. So it's going to be HH for the hour component, 2 small m's for the minute component. So that's going to tell Java that I want 2 digits that represent the minutes, mm, and you'll see I'm using colons here to separate the hours and the minutes, and then I can also have 2 small s's to represent that I want a 2-digit representation of the seconds. Okay, so that's what my date string format is going to look like. Again, there are all sorts of different ways you can represent dates and times. You should go and have a look on the Java documentation for that. Okay, I'm going to keep it straightforward enough though here. So now that I've created my SimpleDateFormat object, I can now use that to convert my epoch time into something more readable. How do I do that? Well, what I'm going to do is I'm going to create a string here, and I'm going to call it str_date, and I'm going to say that that equals date format. So date format is this SimpleDateFormat object that I've just created, and the date format class has a method called format. So that actually takes the epoch time and it converts it into that new format that I've just specified. So what do I need to pass over to this format method? Well, I need to pass over a date object. So I can pass over my date object that I just created up here, which is called now. So I can pass over now, or now is my date object that I created. So I can just pass it over like that. And then I now have a string that is formatted in this way that I've specified here, and it's going to contain the current time, DD, MM, YY, YY, and then the time component, 2 H's for hour component, 2 digits for the hour, 2 digits for the minutes, and 2 digits for the seconds. I can print that out. I can just do a simple system.out.println, and I can print out my str_date. Actually, why not? Let's print out a message here as well. Current date and time, and we can print that out and we can see what that looks like. So let's save that, and let's go back out to the terminal window. So I'll save my code. Let's clear my terminal window here, and I'll recompile. So javac, hopefully we have no errors. Yes, thank you, we have no errors, and let's run this. And now you can see we get our epoch times and we get our formatted time. Okay, so we can see that the date is the 6th of the 5th, 2020, and it is that time. It's quite late at night. See, I'm dedicated up making videos for you guys late at night. Okay, so you can see how late I'm working. This is a really good video to show my dedication. So anyway, here we go. That's the date and time, nicely formatted. You can see that we have it in some readable format, and we can read the time here as well. Okay, so that's pretty good. We've got this way of formatting a date and we can specify all sorts of different formats. Now, just to play around with this a little bit, what about if we just wanted the date? Let's say we didn't want to display the time here for some reason. Let's say we just wanted the date. Well, I could take my format string and I could just take the time away. I can just take it away and have the date part. And if I save that and run it now, let's clear my output window, recompile and run, and now you can see that in fact we just have the date part of this. The time bit isn't shown. Why is the time bit not shown? Well, time bit isn't shown because it's not part of our format string. Okay, if I put it back in there, it will reappear. Okay, so I could have my fully formatted string like this, or I can take various different pieces out and just display those pieces. For example, if I took everything out here and just left DD, for example, what do you think that's going to display? Well, it's just going to display a 2-digit day number for me. So let's save that and let's go over here to our terminal window, and I'll recompile once again, and I will run the program again, and you can see now that it just displays the day component of the current time, which is the 6th of, well, happens to be the 6th of May, but it's just displaying the day, right? So this is very flexible. I can do all sorts of things in here with this string, and as I said, you need to really go and have a look at the Java documentation to see all the possibilities and all the different string format specifiers that we can use there. Okay, so what I want to show you now is how we can take this idea of storing a date and put it to some use. Okay, so we're going to take this inbuilt Java date class, and I'm going to show you how you might go about using that. Okay, so let's say, for example, I'm going to go up to the top of my code here, and I'm going to create another class, right? Just I'm going to create it in the same file here just for convenience, but obviously you could create it in a separate source file. But I'm going to create a class called log message. Okay, now this class is going to represent the idea of a log, a system log, and we write messages into a system log, right? That system log is usually a file on the hard disk somewhere. But I'm going to write a class that represents a very simple system log message. Okay, and in that system log class, I'm going to have private string, and I'm going to have message MSG. So it's going to be there's going to be a string message in there. But I'm also going to have the idea of a timestamp. So each message that's written to the log file, for example, would have a date and timestamp of when that message was written to the log file in order to try and record when that event happened, right? And this date and timestamp data member that I have here is going to be a date object. Okay, remember this date that I'm using here is the inbuilt Java date that is part of the util package in Java. So my log message class is going to have a very simple string that represents the message, and then it's going to have a timestamp, and that timestamp is going to be of type date. Okay, I'm going to have a constructor, so let's write the constructor. So log message. Now my log message constructor is just going to take one parameter, and it's going to be a string, and it's going to be the message that I want to give to the log object. In the body of the constructor, then what I'm going to do is I'm going to set that message. So I'm going to say this dot message equals message. So this dot message, remember, refers to the internal data member here in the log class, and this message on the right hand side of the equals represents the formal parameter message. Now what I'm going to do is, once I have the message set in my log class, what I'm going to do now is I'm going to create a date object. So when the log object gets created, when its constructor gets called, it's also going to create a new date object. And I'm going to say timestamp, all right, which is my internal data member here. All right, I'm going to say timestamp equals new date. So new date. Okay, now this line of code is going to take my internal data member called timestamp, which is of type date, and it's going to create a new date object. So timestamp now is a new date object. And what does new date object do when it creates a new date object? It gives us the current time in Epoch Time, Unix Epoch Time, okay? Number of milliseconds that have elapsed since the 1st of January 1970, 0-100 hours. So timestamp is actually going to get the current time just by creating this new date object, which is brilliant because now my log object will have a date and timestamp of when it got created, and I can just write that to a log file, for example. The other thing that I'm going to do here is just to illustrate how this will work is I'm going to add in a public method that's going to return a string, and it's going to be called toString. So we've seen this before. Very common for classes to have a toString method to kind of allow you to print out the contents of the object. Okay, so the toString method is going to print out the date and timestamp and the message that the log object contains. But remember, I want the date and timestamp to be printed out in some readable way, so I'm going to have to format that. I already have the code down here that I can use to do that, so I'm going to just copy my SimpleDateFormat code up here. I'm going to, in my toString method, I'm going to put that in there, and I am also going to create that string, so I'm going to have that in there as well. I'm just copying this code up into my toString method, so I'm going to have string strdate equals date format dot format, and I'm not using now here. I want to format the timestamp that the log object has, so I need to say dot format and pass over a parameter of timestamp, because timestamp is the timestamp that I'm using in the log object. Okay, and so that's actually going to now have the date and timestamp of that log object nicely formatted for me in this string strdate, and I can just return a string now that has the timestamp and the message. So I can just say return strdate plus, and I'll use a space to separate out the timestamp from the actual message that the log object has. Okay, so this is just a very simple kind of example of how you might use the Java date object to give a kind of timestamp for something. Okay, so what I'll do now is down in the main program, down in the main parts of the program that I have here, I'll create a log object. So I'll say log message lm1, for example, equals new log message, and I'll give the message the log message a message to output to the screen. So what will we say? Error. Let's say fatal system failure, for example. Okay, that would be a pretty drastic log message to encounter, wouldn't it? But anyway, it's just a silly little example. So we're creating a log object here called lm1, and when that log object gets created, of course it will get this message as a parameter, and also the constructor of the log message gets called, and when that constructor gets called, it creates a new date object, and that new date object will have the current time. So what we can do is we can print out that log object. So I can say system.out.println, and I can say lm1 dot, and I can use my toString method that I created, and that's going to allow me to get a string that represents the contents of that log message, right? just going to print it to the screen. So I'm going to save this, and hopefully when I go over here to my terminal window and I compile my code, let's compile that. Okay, no error messages, that's good. And let's run the code, and you can see now that we have a new line of output, and you can see that we have the date and time stamp for our log message. Okay, so we have the date, we have the time, and we have the message. So we could have a whole bunch of these log objects. We could create loads and loads of log objects that represent different events with timestamps and messages, and we could, for example, write those to a file if we wanted to create a log file. Okay. What else do we need to know how to do with dates and times? Well, so far all of the examples have been around the current date and time, but that's not always what we want to do. Some of the time we want to actually create a date that just represents an arbitrary date and time. So maybe we have a calendar and we want to create an event in our calendar, or we might even want to represent some date in the past or something like that. It's not always the case that we want to deal with the current time. So how do we do that? Well, we need to introduce another class or another inbuilt Java class into the mix here. So what I'm going to do is I'm going to import two different classes. I'm going to import java.util.calendar. Okay, and I'll explain why I'm importing this in a minute. And I'm also going to import java.util. And I'm going to import something called the Gregorian calendar. Okay, so these two packages, these two classes that are part of the Java util package, I'm going to use these two classes to represent an arbitrary date and time. Okay, just some date and time. That isn't the current time. It could be a time in the future, or it could be a time in the past. Okay, or any date and time that I wish to represent. Okay, so I'm going to use these two classes to do that. So I'm going to go down into my main program, and let me move this up a little bit so you can see it. Let's make it a little bit bigger as well. And what I'm going to do is I'm first of all going to create a date. Okay, so I'm going to say date, and then I'm going to call it some date. All right, so whatever date I want to represent, I'm going to say that equals a new, and I'm going to use this Gregorian calendar class. So I'm going to say new Gregorian calendar. Now the Gregorian calendar, you can look this up again in the Java documentation. The Gregorian calendar class allows us to just represent some calendar date, and it takes a number of parameters. The first parameter that it takes is the year parameter as an integer, so I can give it the year 2020. The second parameter that it takes is the month number. Okay, now here's where it gets a little bit interesting. I'm going to use this calendar class, the calendar class that's part of the util package. I'm going to say calendar dot May. Okay, so the calendar class has a whole load of these constants. All the months are defined within the calendar class: January, February, March, April, May, June, July, and so on. They're all defined in there. Okay, so when I want to represent the month, I can say calendar.May, and then the final bit that I want to represent is the day, and that's just another integer. So the day today happens to be the 6th of May. Okay, so I can create a Gregorian calendar object like that. So it's going to create a calendar object. Now what I want to do is I want to now represent that Gregorian calendar date as an epoch time. So to do that, once I create it, I create this new Gregorian calendar object here, and then I can call .getTime, and that method .getTime will give me that Gregorian calendar date as an epoch time, okay? Because the date here, the left hand side of this equals, is a date object, and that date object represents an epoch time, okay? This Gregorian calendar represents a calendar date. So I have created the calendar date that I want, but now I get the epoch time representation of that, and I can store it in my date object. And I could use that date object then as part of another class or whatever I want to do with that. Of course, when I want to output that date, I still have to use my my date formatter, so I can reuse that. So for example, I could say let's say, let me see, what do I want to do here? I could say string greg date equals, and I can use my date format from before. I'll reuse the one that I have up above, date format dot format, and instead of formatting now, what I want to do is format some date. So I'll pass over some date. Okay, and let's print that out. Let's say system.out.println, and I'll print out Gregorian date, and of course I'm going to print out my string greg date. Okay, let's save that, and let's go back to our editor, or our terminal window over here, and let's actually clear the window. Let's compile. So we can compile that. It compiles okay, and let's run it. And now you can see we have a new line of output, and this new line of output is the Gregorian date that I created. Okay, so this line of code here represents this date that's being output here in our output. Now you'll notice that the date bit is fine. Okay, the 6th of the 5th 2020, but this time bit here is all zeros. I wonder why that is. Well, it stands to reason really, because I didn't specify a time for this Gregorian calendar date. Okay, I just specified the year, the month, and the day number. So I didn't specify a time. So when I try and print it out using that format, DDMMYYYYYYY, and hours, minutes, and seconds, well, I didn't specify an hours, minutes, and seconds, so it doesn't know what to do. So it just prints 000. Now I don't have to have that. I could use a date format that didn't have the time. Okay, just displayed the date. I could do that, or I can actually specify a time in my Gregorian calendar format. So if I pass over some more variables, so let's say I could pass over say the hour. So the hour might be 1, and the minute might be 1, and the seconds might be 0, for example. So let's pass that over. So you can see there I've just passed over 3 extra parameters here. Okay, so 1, 1, and 0. All right, and when I compile my code again, let's clear our window. Let's compile. And let's run the code, and now you can see, because it passed over some values for the time in my Gregorian calendar object, I now get some time output over here, okay, in my output. And as I said, I don't have to specify the time. If I just want to specify a date, I can do that, and I can change the format of the string that I want. I could just get rid of the hours, minutes, and seconds and just print the date if I wanted to. Okay, so it's very flexible. So that kind of pretty much covers it as a basic intro to the idea of epoch time, the idea of Unix time, storing time, as a 32-bit integer and the problems with that, and then moving to a 64-bit signed integer representation of time. The idea of, you know, storing time as the number of milliseconds and then having to convert from that format into something more readable, and also creating some arbitrary calendar date and time using this Gregorian calendar class in Java. So look, that is really kind of just the tip of the iceberg when it comes to dealing with dates and times in Java. There's so much more that we can do, so much more classes that are built around handling dates and times in Java that we just wouldn't have time to go into now. So hopefully that gives you some basic introduction to handling dates and times in Java. If you liked the video, please subscribe to the channel, give the video a thumbs up, leave some comments down below. Don't forget to hit the notification bell. There will be more videos on the way, and if you found this one useful, you'll find the next one's useful as well, so you'll get notified whenever I upload a video. And once again, thanks for watching, stay tuned, and I'll see you later.